Alright, so let's take a look at the rest of problem 1, part B. We have two functions, f and g. We want to build a new function, and we could call this function anything. We could call it h or whatever, but instead they give it the name f over g just to help us understand how it was built, so how they created it. So this is just notation for f of x divided by g of x. Alright, so we see that we have a complex fraction, a fraction within a fraction, and they expect us to simplify our fractions. We do not want to leave this as a complex fraction. When we divide fractions, we can rewrite it as multiplication if division is the same thing as multiplication by the reciprocal. So my numerator I leave alone, but I can change this division to multiplication if I take the reciprocal of my divisor and we just flip it. So as we mentioned before, that when you multiply fractions together, you just multiply straight across the numerator and straight across the denominator. But just like in part A of this problem, we want to factor our denominator and write this fraction in lowest terms. We have a factor of x minus 1 in the numerator that will that will cancel with a factor of x minus 1 in the denominator. X squared minus 1 is the difference of squares, and we know that a squared minus b squared is equal to a plus b times a minus b. So this is x squared minus 1 squared. 1 squared is 1. So when you have common factors, they reduce. Now you can't do that with terms, but you can do that with factors. So we have our final answer. This new function f over g of x is equal to that. So this is our final answer. So I hope that helps.